This is Chapter 2, Exploring Data with Tables and Graphs. 2.1, Frequency Distributions for Organizing and Summarizing Data. Lots of vocab again. We have a frequency distribution is a table which lists each category or classes of data and the number of occurrences for each category of data. We have classes is the categories in which the data is organized. Frequency is just the number of times it occurred. We have a lower limit, which is that smallest value that we have, an upper limit, which is the largest value that we have, and that's within the class. Class width is the difference between consecutive lower class limits, definitely something we need to know. Open-ended is if the first class has no lower limit or the upper class has no upper limit. Midpoints is the mid value between that lower class limit and the upper class limit. You add those two values and divide by 2. The example down here is a frequency distribution with grouped data. So the ages of the people under sentence of death as of December 31st, 2008 in the U.S. are listed in the table below. And you'll notice that the first age that we have is 20, and that group goes from 20 to 29, and there's 266. 30 to 39, there's 952, and so forth. You'll also notice that that last class says 60 and older, so we don't know exactly when that age is the highest age that we have in this data. So part A says determine the class width. If you look up above, the class width is determined by consecutive lower class limits and subtracting them. So your lower class limits, like the first one that we have is 20, the next one's 30, the next one's 40, and so forth. So if you were to subtract two consecutive ones, let's just say the first two, you would have 30 minus 20, which is equal to 10. Is the table open-ended? Yes, because this last group that we have is 60 and older. And then we have the next question says, determine the lower class limit for the third class. So we have the first, second, and third. And so determine the lower class limit for the third class, that would be 40. And the upper class limit for the second class would have been 39. Is the data discrete or continuous? I know we're talking, it says the number of people, but that's just the frequency. The data that we are talking about is ages, and ages is something that's measured, and this is continuous like we saw in the last chapter. Next thing we have is to construct a frequency table. I'm going to leave that for you guys to look at on your own. We usually don't have to actually construct it on our own. Most of the time they are given to us and this would not be asked, but definitely a good idea if you were to be doing this in another class. Next thing we have is the relative frequency and relative frequency distribution. That word distribution just means table. So we have relative frequency is how often something happens divided by all outcomes, and a relative frequency distribution lists all categories of data together with the relative frequencies. The formulas that we have here are the relative frequency for a class is the frequency for the class divided by the sum of all the frequencies. The percentage of this would be figuring that out and then multiplying by 100 to get 100%. Next thing says the sum of the percentages in a relative frequency distribution must be very close to 100. They should be exactly, but because of rounding errors, there might be a little bit of an issue going on, and it should be between like 99 or 101%. With little wiggle room for rounding errors. The example says represent the weight of each 2015 men's U.S. soccer training camp member. Use the data to construct a frequency distribution, relative frequency distribution, and cumulative frequency distribution. So first thing is that you need to find the smallest weight that we have and also the largest weight. And let's figure out what those two values are. You notice the smallest weight that we have is 135 and the largest is 215. So for you guys to figure out where and how to set up our data and group this data together, I'm going to take 215, which is my largest, and subtract my smallest, 135. And I'm going to say, let's go ahead and make 5 classes. So I'm going to divide this by 5. On an exam, you will not be asked to do this on your own. However, if you are collecting your own data, you would have to do this and figure out how many classes you wanted to have. This works out to being 16. I'm going to go ahead and say let's just round up to 20. Makes it a little bit easier to count, by 20s than it is to count by 16s. So what that means is when we go ahead and create our distribution, which is our table, go ahead and make a column here, and the column is going to be weights. And so the first weight that we have, I'm going to pick a value to start with. I'm going to go ahead and say, let's start with 130. And so that means we're going to go from 130 to, and our class width that we're counting by is 20. So the next lower class limit that we have, if you add 20 to that, would be 150. And so that means that the upper class limit of our first class would go to 149. Likewise, the third class lower limit would be 170, 190, 210, and then let's go ahead and see how far we are with our data. Do we have enough to include the person that weighs the most on the team, which is 215 pounds? So this would go to 169, this would go to 189, this would go to 209. And if you need help with the next one, think the next lower class limit would go to 230, so the one before that would be 229. And yes, that last class that we have there would include the person that weighs 215 pounds. So next thing we need to do is come up with a frequency distribution. To do that, we're going to put a frequency column over here. And in order to figure out the frequency, we need to look at all of our data and find all the men that weigh between 130 and 149. So if you scan your data, I usually underline or circle or do something, but 130 to 149. So we have one here, and one down here. So we have a total of 3. You want to count, again, make sure, especially if it's an exam, make sure you didn't miss anything. I'm going to go ahead and put the other numbers in. Make sure you try to do those on your own to make sure you know how to count and find those. So that was the first thing that it asked for in the directions. The directions said to find a frequency distribution. We just did that. The next one says to find a relative frequency distribution. To do that, we need the total for our frequencies, and if you add these all up, we get 26, which is the total number of men that are on the men's U.S. soccer training camp team. So to find our relative frequencies, we need to take these values that we have for our frequencies and divide by the total. So I'll write it out for the first few. So the first one's going to be 3 divided by the total, which is 26. The next one's going to be 8 divided by 26, then 11 by 26, and so on. We usually do not write these as fractions. They're normally written as decimals, so let's go ahead and round 3 decimal places for this. So I'm going to go ahead and say this is 0.115. We have 0.308, and then 0.423, and then the other values we have are 0.115 and 0.038. So that is a relative frequency distribution. Next one that it wants us to do is a cumulative frequency distribution. So again, we're going to make another line on here to separate my data. And we'll put this in as our cumulative frequencies. So we use the word cumulative a lot in different ways. We use that when we talk about our final exam that we have. So your final exam is what we just learned and everything before it, meaning that it covers the whole semester. Same idea here. So the first one that we have is just 3. To find the next one, we're going to add up 3 plus 8, which is 11. The next one, we're going to go ahead and add up 3 plus 8 plus 11, which works out to being 22. The next one, we would add up 3 plus 11 plus 8 plus 3, which works out to being 25. And then the last one, you would add up all the frequencies together, which would be 26. So a couple things to note. The total number of men was 26. That should match with the ending value that you have for your cumulative frequencies. The other thing too is if you were to add up your relative frequencies, I know we rounded, but we do get 0.999, which is very close to 1, which is what it should be. And so those are some ways to check to make sure that you did those problems correctly as you're going through those. The next thing that we have is the normal distribution. This is going to be big for us later on. It's a distribution that starts off with a low frequency, increases to high frequency, and then decreases again. It's also symmetric, so we'll get more into that later. We can combine two or more relative frequency distributions in one table, and it makes it easier to compare. So the example here says construct a relative frequency distribution for both store brand chocolate chip cookies, state and observation. So I'm going to go ahead and circle that problem, and we will go ahead and do that together, but we are going to have to separate this into two columns and do both relative frequencies for both types of cookies. Section 2.2 is on histograms. A histogram is constructed by drawing rectangles for each class of data. The height for each rectangle is the frequency or relative frequency of the class, and the width of each rectangle is the same, and the rectangles touch each other. One way that a variable is described is through the shape of its distribution. And so we have what's called uniform distribution, bell-shaped distribution, skewed right, and skewed left. These are going to randomly show up throughout the semester. Uniform, the frequencies are the same. If you look at the graph next to that histogram, it looks like a rectangle. The heights are all the same. Bell-shaped, again, is where it starts off low. It goes up to a high point and then decreases again. Skewed right, if you notice from the highest point that we have, there's a longer tail over on the right side. And so it says the tail on the right of the peak is longer than the tail on the left of the peak. And then the opposite is for skewed left. The highest point that we have, the tail on the left is longer than the tail on the right. So to determine if the data comes from a population that is approximately normally distributed, a normal quantile plot can be used. The exact process is covered in section 6.5. If the data distribution is close to normal, the plotted points will lie close to a straight line. Below are some examples of histograms and their corresponding normal quantile plots, so we will look at this together. Section 2.3 is on graphs that enlighten and graphs that deceive. So first one that we have is a dot plot. There's a bunch of different graphs in here. Definitely something you want to make some study cards, some flashcards, something along those lines, or outline the sections. So a dot plot is a graphical display of data using dots. Each dot represents one observation and are stacked in columns over the categories. So the heights of the column represents the frequencies or the relative frequencies. Dot plot is limited in usefulness, however, provides a quick picture of the data. Example, Ms. Harper's AP Calculus class has 14 students. The scores for the last exam are listed below. Create a dot plot. So in order to do this, we're going to make a line for our data. The lowest exam score that we have is a 64. And the largest exam score that we have is a 96. So I'm going to go ahead and start this at 60. Count by 5s. Or I'll count by 1s, but only mark down the, so 65, 70, 80, 85, 90, 95, and then all the way out to 100. And what we're talking about here is AP Calculus scores. So we'll put down AP Calc scores. You need to label your axes so we know what it is that you're talking about. And then for each child, each score that we have here, they get a dot. So the first one that we have is 77. So we go ahead and put a dot above that data point. The next one is 85, gets a point above 85, 73, 64, 90, 80, 81, 84, 96, 66, and so forth with these, so 66, 77, which we already have, so since we already have a dot there, we're going to put the next dot right above it. So they line up in a vertical column. 79, 70, and 82. So it allows you guys to see each dot represents one student in this class. You should have a total of 14 dots. Next thing we have is a stem plot or a stem leaf plot. It's another way to represent our data graphically. So it's the same data that we have from above in the previous example, and what we're going to do is we're going to use the digits to the left of the rightmost digit to form the stem, and each rightmost digit to form a leaf. For example, 147 has a stem of 14 and a leaf of 7, or 12.3 has a stem of 12 and a leaf of 3. So we're going to draw a line that separates our stems and our leaves. And if you notice, we have every single exam is in the form of either 60s, 70s, 80s, or 90s. So we'll start at 60s, 70s, 80s, and 90s. That means that I already have those grouped in those values. So in the 60s, we have a 64 and a 66. So the smallest one we have is a 4. The next one we have is a 6. So you would read this as 64, 66. There's no commas in between these. If you go ahead and circle all the 70s that we have a 77, 73, 77, 79, and a 70. I'm going to put these in order from smallest 70 value to the largest 70 value. So the first one we have is 70, then 73, then 76. We have a 77, 77, and then 79. In the 80s, we have 80, 81, 82, 84, 85. So I'm going to put those in order. So 80, 81, 82, 84, and 85. And then in the 90s, we have two of those. We have one that's in the 90s and one that's 96. So 90 and 96. The next graph that we have is called a time series plot. It's obtained by plotting the time in which a variable is measured on the horizontal axis and the corresponding value of the variable on the vertical. Line segments are drawn to connect the points, so we need to connect our points in straight lines. So the data here on this example says this represents the total amount in inches of rainfall in LA over a 5-year period. Use the data to construct a time series plot. So in order to do this, we're going to have a vertical axis and a horizontal axis. On the vertical, we are going to have your annual rainfall. The smallest value that we have is at about 9, and the largest one we have is just a tad over 20. So I'm going to count by 5s. And labeling this is annual rainfall. On the horizontal, we are going to go ahead and put the time. Those are years. So these are years. And the year that goes from 2008 to 2012, we need to put that earliest year first. So 2008, I'm going to write this as 08. We had 09, 2010, 2011, and 2012. From here, I'm going to go ahead and put points for each one of these. So in 2008, there was about 13.53, so do the best you can with putting your dots. 2009, we had 9. 2010 is 16. 2011 is 20.20. And 2012 is 8.69. So with these points, it says that you need to use line segments to connect them. So do the best you can, connecting those with line segments. And that's a time series plot. Next one that we have is called a bar graph. A bar graph is constructed by labeling each category of data. So this is qualitative data on either the horizontal or vertical axes, and the frequencies or relative frequencies on the other. Rectangles of equal width are drawn on each category, and heights for each rectangle represent the categories or relative frequencies. And with these, the bars do not touch. So bars don't touch. So the next example that we have says, an 8th grade teacher has 20 students in her science class. The final grades for the 20 students are listed. It says create a frequency distribution and a frequency bar graph of the data. So there's all the data there. There's a table already set up for us. There is a tally column in there. Some students really like to use tally columns, and it allows them just to kind of tally and put lines for each one. I'm not going to do that just to save some time, but you guys can definitely do so. I'll cross that out, but definitely something you could do on your own. So I'm going to go ahead and write those numbers in that we have, but check to see that you have these on your own. So I have an A, there's 2 of those. A minuses, there's 3. 1, 2 B's, 3 B minuses, 5 C pluses, 3 C's, 0 C minuses, and 1 D. So now our bar graph over here that we have, so it's asking us to do a bar graph, and draw our vertical axes and our horizontal axes. And the vertical is going to be frequencies. The largest frequency that we have goes from 0, which is the smallest, up to 5. So I'll just count by 1. So 1, 2, 3, 4, 5. And then I'm going to go ahead and on the horizontal, I'm going to put down the different grades that we have. I'm going to go in order. Technically it doesn't matter, but it does make it a little bit easier since that's how the table is done. So we have an A minus, B plus, B minus, C plus, C minus, and D. And from here we're going to make vertical rectangles that correspond to each grade's frequency. And I'll go ahead and label this as grades. So for A, we have 2. And for A minus, we have 3. Again, do the best you can. B plus, there is 1. And if you notice, there's spaces left between these. The rectangles are supposed to be equal width, and the spaces should be also equal too. You know, it's difficult to do by hand. So we have 2 for B's. B minus has 3. C plus has 5. C's have 3. C minus, there is nothing. We just leave a space there. And then for D, we have 1. So if you notice, a lot of students get this confused, a bar graph confused with a histogram. Bar graphs, there are spaces in between those bars. This is categorical data. And with a histogram, it is where the bars touch. It's numerical data. So we have a Pareto chart. Is a bar graph whose bars are drawn in descending order of frequency or relative frequency. And this is also a bar graph. So it would be rearranging what we just did with the descending, so the highest grade down to the lowest. Next one that we have is a pie chart. It says a circle divided into sections. Each section represents a category of the data. The area for each section is proportional to the frequency of the category. So we are going to go ahead and try the example together in class. Next one we have is a frequency polygon. And it says a frequency polygon is a graph that uses points connected by line segments to represent the frequencies for the classes. It's constructed by using class midpoints as heights equal to frequency. So frequency polygons provide the same information as a histogram. And then we have what's called a relative frequency polygon. And so a relative frequency polygon is a graph that uses points connected by segments to represent the relative frequencies for the classes. It is constructed using class midpoints, and heights equal to the relative frequencies. So I'm going to sketch a little pictures on these just to hopefully kind of help us out and add a few things. So first of all, when you graph a frequency polygon, we are going to have midpoints on the horizontal and frequency on the vertical. And then likewise for your relative frequency polygon, it's going to be midpoints. And instead of frequency, we're going to have relative frequency. And then there's a note for both of these that we're going to add in. And that is extend ends of your graph on the left and right so the graph starts on the horizontal line, so graph starts and ends on horizontal line. And this is for any polygon. So that means that this note is going to go to both relative frequency polygons and to frequency polygons. So for both of these. So just so we are aware of that. So group data are formed by putting individuals of observations into groups. We've seen group data quite often. We put the data in for the soccer team, and then we also had it for the people that were on death row. And so there's a little reminder here for midpoint, because we will be using that with group data, and we saw this earlier. But we're going to take our upper limit plus our lower limit and divide by 2 in order to get our midpoints. So the example below says monthly rain totals in inches are represented in the table. Construct a frequency polygon of the data. So if you notice we have grouped data, and that data is grouped. The first class goes from 2.01 to 2.75 and tells us the frequency that goes with this. If we need to do a polygon, that's what we just discussed, you need to have midpoints. So in order to get midpoints, we are going to go ahead and make another column. And to make another column, and to find our midpoints, we are going to add together our lower bound and our upper bound and divide by 2. So see if you can do that on your own. We covered this back in the previous sections. So to do that, we get 2.38. We get 3.13. We get 3.88. We get 4.63. 5.38 and 6.13. So we need the frequencies and the midpoints. So we have enough data right now to go ahead and start our polygon. So let's go ahead and draw our axes. So our vertical is for frequencies. Largest frequency that we have goes up to 11, and the smallest we have is 1. So I'll start at 0 and go up to 11, counting by ones. And then down here on the horizontal, we are going to be using our midpoints, but we don't write midpoint. We're going to write that this is rain totals. So monthly rain totals. And again, this is in inches. And then your vertical again is frequencies. I'm going to count those by ones. Okay, so when I go ahead and put my numbers in, I want you guys to leave one dash here that we will fill in. There's a special note that we wrote down, and we're going to equally space these. So the first one is the midpoint. The first midpoint that we had was 2.38. And I'm going to go ahead and put the rest of those midpoints in. Okay, and again, I'm going to put another little dash at the end of this graph. And those little dashes, I'll make a circle here. We do not have numbers in right now, but to find those, I need to have a starting and an ending value. To do that, I need to figure out what it is that we are counting by to go from one to the next, to the next, to the next. And to do that, you can subtract them. Subtract 1 minus the one before it, and when you do, you get 0.75. And so to figure out the very beginning one that we're going to use, I'm going to take my midpoint, which is 2.38, which is my first class one, and I'm going to subtract 0.75, which works out to be 1.63. So that would go on my first little dash. And then the last little dash is going to be my last midpoint that we have, which is 6.13, plus 0.75. And when I go ahead and do that, we get 6.88. And then on my graph, that's what's going to be on the last little dash. So 6.88. So make sure you guys have those values in. From here, we're going to go on and put dots for representing our frequencies and our midpoints. So at 2.38, we have 5. At 3.13, we have 11. And then continuing in this for the rest of our data. And then it says that we're going to make line segments connecting these points. So again, do the best you can. But we are drawing line segments that connect these points in order. And then the last thing is what we added in, which says we're going to extend those ends down to the horizontal. So if you put at the horizontal line, at those two values that we added in, which was 1.63 and 6.88, put 2 dots there. And we're going to extend our graph down so it starts at that value and it ends at that value on the horizontal. And this again is a frequency polygon. So together in class, we will look at the rest of the notes, which does cover a frequency histogram,